sine of 0 is 0. So we get 0 on top. On the bottom, 3 squared is 9. 9 minus 9 is 0. So we do get the 0 over 0, right? That is bad. Okay, so now we start thinking junk, right? Do we have junk? Top and bottom, do they match? No, they don't match, do they? So can I say that this is 1? No. Any ideas then? You have a difference of squares on the bottom, right? So why don't we factor it? All right, so limit x approaches 3, sine x minus 3. Okay, on the bottom, this turns into x plus 3, x minus 3. Now that's very fortunate, right? Because now we have junk and junk. You see the junk? They're exactly the same. This and this are exactly the same, and they both go to 0, don't they? But there's an issue. We've got this, right? And the formula I gave you didn't have some other junk, right? It didn't say you could have other junk. So watch what I do here. Last class, I gave you the limit laws, and the limit laws said that if you're taking a limit of a product, two things multiplied, you can do the limits individually. So I'm going to use that limit law, and watch the way I write this. I'm going to do sine of x minus 3 over x minus 3 times the fraction 1 over x plus 3. I need you to agree that this expression is exactly the same as this, right? Because how do you multiply fractions? Straight across, right? So if I do this times this, right? This times 1, I get that. And if I multiply this times this, I get the bottom, don't I? So that's completely legal for me to like rip that apart into two fractions. And then the limit law says that I'm allowed to look at each one of these individually and get the answer to each one. And then whatever answer I get, I will multiply those two together because there's multiplication right there. So what does this turn into? Sine of junk over junk. The junk goes to 0. We're taking the limit. It goes to 1. So this goes to 1. This, plug in 3, right? I get 1 on top. And on the bottom, I get 3 plus 3, which is 6. So your answer is 1 times 1/6, which is 1/6. Y'all see that? Questions? I'm not sure what the looks on your faces today. Y'all okay? No questions? Yes?
I still don't really get how, like on the left side, the first example, I just don't really get how that's 1.
You have to believe me when I tell you it's 1.
That's a believing thing.
Yes, that's the believing thing. Don't, yeah, I mean, if you need to like convince yourself, just temporarily convince yourself, then let me graph, I'm going to graph sine x over x. I'm going to graph that function, all right? If I graph it, there's the graph of that function, okay? Now, if I try and plug 0 into this, I get 0 over 0, right? So it should be, at 0, it should be undefined. Oh, did y'all see that? Right? I can't do it. I can't do it. There. Okay, do y'all see at 0 it's undefined? So there's a hole there. But can you tell what the limit is as I come in from both sides? It's 1. Now that's only, you still are believing it just based on the graph, but that's all I can give you at this point. Is that okay?
I just wasn't sure if that was something that I was supposed to have like.
Nope. I'm telling you that when we have sine of junk over junk, or the other way around, if you have junk over sine junk, as long as the junk matches, as long as the junk goes to 0, your answer is 1. Okay? All right, so for this one, we almost had sine of junk over junk. Fortunately, it factored, and because it factored difference of squares, we could break it up into 2, and we could do it, right? Let's see if I can, I'm going to really kind of push you here. What about this? What if I did it the other way around? Students have trouble with this one. Right, so let me ask you first. If you let x go to 3, do you get 0 over 0 there? Do you get 0 over 0? Yes, right? You do get 0 over 0. Because that 3 here, that's 9, 9 minus 9 is 0. Sine of 0 is 0 from pre-cal. And on the bottom you get 0, so you get 0 over 0. This is bad. Now, do you have sine of junk over junk? No, not exactly, right? So last time we did difference of squares, right? And then we split it into 2. That's not going to work this time. Why is that not going to work? Let me try it. If I do this, and I would have to do the difference of squares inside the sign, wouldn't I? That's what I would have to do. Can you split this sign into 2 pieces? No, you may not, right? And that goes back again to pre-cal. In pre-cal, we have a formula, and it's on your formula sheets, that if you have sine of, let's say, x times y, this does not equal sine of x times sine of y. That's not true. If you have multiplication inside of a sign, you can't like distribute the sign through to each one. No go, all right? So since we can't do that, what in the heck are we going to do? Let's see if anyone has an idea. You have an idea?
Multiply the top and the bottom by the conjugate of the bottom.
Okay.
Give you the x squared is what you're looking for.
Exactly. So what's the problem with this one? We can't split the sign up, right? We would love to have, what would we like to have down here? Exactly what's up here, right? Wouldn't it be nice if it was x plus 3 times x minus 3? Then the junk would match, right? So since we would love to have an x plus 3 down there, let's make an x plus 3 appear. And the only way to make an x plus 3 appear is to multiply the top and the bottom by x plus 3. We are introducing that ourselves, right? To make it turn into something that we want. It's not a very natural move to do that. I'm not getting a common denominator or anything like that. I'm just trying to make the junks match. So my next line would be sine x plus 3, x minus 3, like that, over, now watch what I do here, x plus 3, x minus 3 times x plus 3 over 1. So all I've done there, because this is multiplication here, these two things on the bottom are being multiplied. With multiplication, you can slide things around. So I move this x plus 3 over here, which leaves a 1 down here. Is that fair? Is that a fair algebra move there? So you'll see now you have sine junk over junk. The junk matches exactly. The junk goes to 0. Right? These match. And because there's multiplication, I can do these limits separately, like this. So what does that go to when I take the limit? I'm ready to get my answer here. This goes to what? 1 times, and then what does this go to? 6. So your answer is 6. Good. All right, we've got more to do. Are y'all ready? This is a weird problem, all right? First step of any limit, let x go to whatever, see what happens, right? X goes to 0. 5 times 0 is 0. Sine of 0 is 0. On the bottom, 2 times 0 is 0. Sine of 0 is 0. So we do get 0 over 0. All right, so maybe we can do the sine junk over junk thing, right? Maybe. But what would our junk be, right? Anyone see what I'm talking about? Like, this is a little weird, right? This is the junk, right, in this one? So we would need what on the bottom in order for this thing to turn into a 1? We would need what? On the bottom here, we need what? It's okay. 5x, right? We need 5x on the bottom, wouldn't we? We don't have a 5x on the bottom. This 2x is inside this sine function, so you can't just like pull the 2x out. You can't do that. It's trapped, right? But it would be real nice if I had a 5x down there, wouldn't it? So like the last problem, we're going to make a 5x appear. We're going to force it to appear. So watch first what I'm doing here. This is pretty standard technique when you're doing these problems. This first step is to just rip it apart into 2 fractions. Is that legal? Is that still the same expression? Right? If I multiply those together, wouldn't I get the top one? Yeah? So we're looking at this, and we're saying to ourselves again, this, well, you know what? Actually, now that we look at it this way, is this a problem? Is this fraction a problem? What happens if I let x go to 0 here? What do I get on top? 0 on the bottom, what do I get? 1. Is that a problem? What's 0 divided by 1? 0. Is that a problem? No, we just can't have division by 0, right? So this actually isn't a problem, is it? This one is a problem. This one's a problem because 1 divided by 0 would be undefined, yes? So I actually need to refocus my attention on this instead of this. So what would I really, really like to have up here that would make this no longer be undefined, but using the junk thing, this would turn into a 1? What would I need on top? A 2x, right? I would need a 2x. So I'm going to introduce a 2x out of nowhere. Just here it comes out of pulling a rabbit out of the hat here. I'm going to put a 2x, and to do that, I'm going to put a 2x on top like that. Now, I can't just do that, right? That's not legal. I can't just throw a 2x in there. But I can do a 2x over 2x, can't I? Because that's 1. So that is legal. And then what I can do is I can take this 2x, and because this is multiplication, I can slide it over here and put it on top of that, and that's no longer going to be a problem, is it? Okay, so let me write the next line. It looks like this. Limit x goes to 0. I have sine 5x over 1 times, now I just put that 2x, slid it over sine 2x, and then times, what do I still have? What do I still have after that fraction? A 1 over 2x, right? A 1 over 2x. Right? That 2x was still here on the bottom, right? I just slid that one over. So let's see where we are now, okay? Let's see where we are. Any questions? So I'm looking at this. This right here goes to 0 over 1. That's not a problem, right? This is junk over sine junk. The junk matches, and the junk goes to 0, doesn't it? So this is going to go to what? 1. So I have 0 times 1. Everything's good so far, right? But what about that? It's 1 over 0. It's undefined, right? So what we've done, I equate this to like this idea of being on a boat, a little like canoe or something, and it's sinking. There's a hole, and you patch the hole, and then you look over here, a new hole pops up, and you like patch that hole. That's kind of what's happening here. We kind of patched this hole. This was a problem. We patched it with the 2x, but then we created a new problem. You'll see that? It's this 2x right here. When you slide that over, right, then you have a 1 over. Right, there's a 1 here, because that 2x came to here. Good? Other questions? Yes?
So the 2x over sine parentheses 2x, that would equal 1 even though the sign is in the
Yes, so if you go back to the note that I had, and I know this is subtle because I go through the note, you look at it for the first time, you're like, what in the world is he talking about? You see this right here? I say that limit doesn't matter what it's going to. If you have sine of junk over junk, right? Or you have junk over sine junk. It can be the other way around. Your answer will always be 1. All right? Thank you for asking. Anything else? So, no problem, no problem, problem, right? How do we go about it now? I mean, you can't say put a 2x on top of this, because if you put 2x up here, you have to put 2x on the bottom as well, right? So you create another problem. Anyone see it? With where? Which one? These two? Well, if you cancel them, then you're back here, aren't you? And if you're back here, this was a problem. Yeah? So that's not going to work. Anyone see it? Let me do it, and then you'll see, all right? For the first time, you'll see it, and you'll be like, oh, wow, okay. I can do that? All right, so look, this is a problem, right? This is a problem. This is not a problem, right? This just goes to 0, yeah? However, if there was a 5x down here, wouldn't this go to 1? Even though it's not a problem, right? This is not a problem, but if there was a 5x, this would go to 1, yes? Well, guess what? I've got an x over here, don't I? That's causing a problem. And because this is multiplication down here, these three things are being multiplied, the order in multiplication doesn't matter. I am free to grab this x and slide it right underneath that, aren't I? Look, go back to when you multiply things. If I were to multiply these three fractions together, the order that I do these multiplications, I could move that 7 next to that 2, do that first, and then multiply by 5. Or I could do 2 times, and I could do 35. Multiplication can be moved around, right? So I'm free to move that x under there, right? If I do that, is it fixed? Not yet. What do I need also? I have an x here. Imagine that x is now here, right? Should I cancel it out here and put it here? I now have an x here, don't I? Have I fixed the problem here? No. What do I need here? A 5, right? I need a 5. How am I going to get a 5? I'm going to introduce it, right? And I'm going to introduce it down here as a 5 over 5. I know this is weird shit, okay? I know it's weird shit when you see these problems the first time, you're like, whoa, okay, what? Why am I introducing a 5 over 5? Think about why I'm doing this. Because what? So I can get a 5 under here so that this thing will turn into a 1, right? But the only way to introduce 5 on the bottom is if you introduce 5 on the top. That's just algebra. You can only multiply by 1. So I'm now going to grab this 5 and take it over here as well. All right? So that 5 will become a 5x there, and it won't be here anymore, right? I know this is strange. I told you it would be. Students normally hate these problems. All right, so let me see where we are. We have limit x goes to 0. Okay, this has now been, we can now write this as sine 5x over 5x. I'm real happy to see this because I know that's going to turn into a 1. And then the next one was 2x over sine 2x. And then tell me what I still have down there. 5 over 2. You still have the 2 down here, and you still have the 5 there, don't you? So you still have a fraction, 5 over 2 at the back. And now at this point, I can go ahead and take the limit. I can use the limit law, and I can do each of these limits separately. So what does that go to? 1. This one? 1. This one? It's just a constant, so it just stays a constant. So your answer is 5 over 2. 5 halves. Weird, huh? We're going to do one more. All right? Now, look, I want to put the original problem up here. This was the original problem. That was the original problem, right? And do you notice that our answer is 5/2, and it's just that number divided by that number? That would be the case if I did this with the different numbers, right? If I did sine of 8x over sine of 3x, your answer would be 8/3, okay? However, on an exam, I need to see work, because there are problems I could give you that would be slightly different where this, just looking at those numbers would not work, okay? So what's more important here is the method and this idea of like ripping it apart, trying to figure out where your problem is, introducing these things, sliding things around. That's the whole point of it. Would you all agree that's a much higher level of thinking than just saying, oh, 5/2? Yes? And that's what we're here for. This is calculus, engineers, computer scientists, right? Even if you're a biology major, right? It's a higher level of thinking. Yes?
How did you come up with like the 5/5? How is that? How are you able to just bring out 5/5?
What's 5/5?
The 5
No, what is it? What's 5 divided by 5?
is 1.
Okay, can you multiply anything by 1 and not change it? So if you take anything and multiply by 1, don't you get the original thing? So we've always, in our whole math lives, always been able to multiply by 1, right? And not change the problem. I'll give you a very simple example. If you take it back, take the fraction 3/4, right? I could rewrite that by, I could, if I want, I could multiply by 2/2, and that would give me 6/8, right? Is that the same fraction as 3/4? Is 6/8, well, they don't look the same, but are they, do they represent the same quantity? Is 6/8 the same as 3/4? Yes. So all I did is multiply by 1, right? Anytime you multiply anything by 1, it remains unchanged. So I am always free to multiply by 1. So the one that I chose was just clever. I picked 5/5 so that I could use that 5 to kind of work that one expression kind of against itself. Does that make sense?
Yeah.
Okay. Yes?
So I know you said that, like, if we saw another example of this, it would be whatever, like 8/6.
Uh-huh.
So is that something that you should double check our work? Like, of course, we still have to go through all of it, but will that always be true? Like, once we get to the end, we're like, oh, this doesn't match up, we know I went wrong somewhere. Is that something you can use?
Here's the only thing I could tell you is for sure, is that is, if you had this, sine of ax over sine of bx, x is going to 0, your answer would be a/b. So you, only if it's sine of ax over sine of ax. If it's something else, it may not be the same. Okay, so this answer is a/b. So if you want to check your work, you could. But only for that. All right, let's look at another example. How about this one? Sine of pi x over tangent of 4x. First step for doing any limit, right, is to check to see what happens when you replace x with whatever it's going to. So here x is going to 0. Pi is just a number, yes? Pi times 0, 0. Sine of 0, 0. Pre-cal, right? Over. All right, here 4 times 0 is 0. What's tangent of 0? So how do you do that? Tangent of 0. You go to your unit circle, right? We're here at this point because that's the angle 0. We're looking at this point. It's the point 1, 0. Tangent is defined to be which trig function over which trig function? Sine over cosine, right? Sine over cosine. The y-coordinate is sine. The x-coordinate is cosine. So when you do 0 divided by 1, you get 0. That's one way you can look at it. The other way to look at it is if you know what tangent looks like from pre-cal, that's the tangent function. What's the value of this function at 0? 0. Okay, that's the other way you would know it. Either way, you are now past this class. You are in this class, so you need to know that that's 0 over 0. Yeah? Remember when we started this class, I said really the big things I want you to be able to do, right? Solving trig equations, knowing the unit circle. This is why we can't be spending 15 minutes figuring that out in the middle of a problem, right? We need time to focus our energy on this. So go get it, brushed up if you need to. Again, come into my office hours, I'd be happy to go over that. All right, we have a problem, right? So there's no algebra here, different squares, conjugate, none of that's here. I'm thinking this is probably going to be sine junk over junk type of thing. So I'm going to first start by ripping this apart. And when I say rip it apart, I just mean separate the sine and tangent from one another. So this is sine of pi x over 1 times 1 over tangent of 4x. No problems there? Everyone good? Pull that apart. Now let's just check to see where the problem is. Is this a problem? That goes to 0. 0 divided by 1 is 0. That's not a problem. Here's the problem. 1 over tangent of 0 is 0. So this is 1 over 0. That's the problem right there. We need to somehow make this no longer be something we don't know. But see, it's tangent, not sine, right? The formula I gave you was sine junk over junk, that sort of thing. Here we don't have sine. However, tangent is made up of sine, isn't it? Tangent is sine over cosine. So I'm now going to rewrite this as limit x goes to 0, sine pi x over 1. And then let me just take my time with this. This is going to be times 1 over sine 4x over cosine of 4x. And that's 1 divided by a fraction, right? And so anytime you have 1 over a fraction, you can flip the fraction over. So how could I rewrite that if I wanted to? Sine pi x over 1 times, instead of writing as 1 over this fraction, how could I write it? Cosine over sine. So cosine 4x over sine 4x. All right. We continue. See that cosine 4x, sine 4x? I'm going to rip that apart. I'm going to pull all this stuff apart so I can really kind of like focus on one piece at a time. Sine pi x over 1 times, let me do the cosine 4x first. It doesn't matter which one I do. I could have done the 1 over sine 4x, but okay. So I've just taken these two. I've left the cosine 4x there, and I pulled the sine 4x to the side. But that's the same problem, right? It's the original problem, just rewritten in a different way. Where's the problem? Where's our issue? First, second, or third factor? Where's it happening? Where's the problem? The third, right? Is this a problem? What's cosine of 0? 1. 1 over 1 is 1. Okay, so that's not a problem, right? This one is still 0 over 1. That's 0. That's not a problem. The problem is here, we get 1 over 0, right? When I say 1 over 0, that's because we're imagining that x is going to 0, which is turning that 4 times x into 0. So that's the problem, right? So what would I love to have up top? 4x. I can't just throw a 4x on top without also doing it on the bottom, because that's how we can always multiply by 1, can't we? So I'm going to multiply at this point the top and bottom by 4x. I'm going to take this 4x and I'm going to dump it right there. See it? So that this would not be a problem, this would not be a problem, and with that 4x on top of this, this would not be a problem either, right? But what would still be a problem? The 4x we have down here. So how am I going to resolve that? Do what? Say it again. Add what? Okay, so if we move this under the cosine 4x, does our formula say that cosine junk over junk goes to 1? Sine. It's only sine, right? So you're on the right track. We're going to move something here, but it's not the 4x, because we can't use the junk thing unless we've got a sine on top and bottom. So move just the x, where? Under the sine pi x. Okay, take just this x. Why not the 4? Well, this is pi x, right? I need a pi x on the bottom, not 4x, right? So I'm just going to take the x and put it here. I'm hoping you can like visualize there's an x there now, right? Yes.
Why can it only go to the sine and not the cosine?
It could have gone to the cosine. Are you saying why is it not in both? Or
Just
why do we pick sine?
we pick either?
No, we can't, because our formula that I gave you earlier said sine junk over junk, right? It had to be sine, it couldn't be cosine, right? There's no formula I've given you yet that says cosine junk over junk is equal to anything, right? So let's just recap. What we have right now, what we have is sine pi x over x, right? Sine pi over x. Would y'all like me to write it there? I'm going to put it there? I'm going to put it there. Okay, so this x has now been moved here, which means it's no longer here, right? Cosine 4x over 1. Here, this is really 4x, right? That 1 is next to it. That's still just 4x on top, and that 4x is gone, right? So we have sine of pi x over x, cosine 4x over 1, 4x over sine 4x. And then over here, what do we still have? 1 over 4. Yes, 1/4? Okay, let's check to see if we've fixed all the problems. Is this fixed? No. Why? You need a pi, don't you, down on the bottom? Okay, is this okay? Yes? Is this okay? Yes, that's going to go to 1 now. And then we have a 1/4 down there. So the only thing we're missing right now is a pi underneath here. So how are we going to get a pi down there? Multiply down there by pi over pi, and then slide the pi over on the bottom. So again, I have to do pi over pi because I'm multiplying by 1, right? That's what I'm doing here. Multiplying by 1, taking this pi, sliding it all the way down here, pi, forget the 1, pi times x. There's no longer a pi there. There we go. I think we are ready now. We're ready to take this limit. I'll write it out one last time to just kind of reiterate where we are. That's where we are. We still had a 1/4, and we still had the pi over 1 here because we took that pi on the bottom and took it down there. And now everything should work. This goes to 1, right, equals. So we're saying equals. We're taking the limit now. This goes to 1, right? This